Using what we know about the basic sine function here, we're going to be able to set up our sine of our 15 degrees and then do our opposite over hypotenuse in order to solve for this opposite here. Now, with any of these trig functions, this may not be the only approach to take. It's just the one that I'm choosing at this moment. So I would solve this for h, so I would multiply both sides by 14.98. So this gives me the height to be equal to whatever this function is when I go on my calculator. So I would take the 14.98 that we found from part 2 here, sine of the 15 degrees, make sure you're in degree modes, not radian, and you should get 3.88 for the value. So it's important to note that this is not the only way to get to that altitude, and also to note that we cannot forget what we previously learned about our trig functions, such as the case of sine is equal to opposite over hypotenuse. And in this case, that opposite is giving us this height here, h, of our altitude of the plane. So for the next one, we're going to be looking at a blimp here. And so it says the diagram shown in the figure represents the height of a blimp flying over a football stadium. Find the height of the blimp if the angle of elevation at the southern end zone, point A, is 70 degrees, and the angle of elevation from the northern end zone, point B, is 62 degrees, and the distance between the viewing points of the two end zones is 145 yards. So the whole paragraph does give you enough information in order to draw it, but they already have given you this figure here, so you can see our blimp was at the top up there, and then they've done my angle of elevation being 70, my angle of elevation being 62, and the distance between them to be 145. So our goal is to find the height here, the height from the bottom all the way up to our blimp here that's off the page. And so what we want to do is we want to think about what we know. First of all, I'm going to find this missing angle at the top. I've got these two angles, but that top angle up there I don't know, so I'm going to say 180 minus 70 minus 62 in order to find my top angle, which is 48 degrees. So I could go up here, and I know up here is 48 degrees. It's important to note that because you can see that we also have the side opposite of it. So we're probably going to be able to set up a sine ratio in order to solve this. And so number 2, what I want to do is I want to say sine of 48 degrees over 145 is equal to, now it doesn't matter whether I go over here and find this side or this side, but similar to the airplane one, once I find one of these sides, I'm going to do sine of that angle in order to find my height here. And so what I've chosen to do is I'm going to do sine of the 48 over 145 equal to sine of 70 degrees over A. So in solving this out, just like you've seen me do in previous examples, I get my A value to be 183.35. So over here, this is 183.35. Now that I've done that, I can now just set up my sine function in order to solve this. And I can just say, okay, well, I know a hypotenuse, and I know down here, say I wanted to find this missing side here, I could do the same thing as I did over here in part 2, and I could say sine of 48 degrees over 145 is equal to sine of 62 over my side B. And so again, solving that out, as we've been doing during this lecture, we get our B to be 172.28. And so now you can set up your sine function either in relation to the 62 degrees and this side, or the sine of 70 and this side. I'm going to work with the sine of 70. So I say sine of 70 is equal to opposite this height that I'm wanting over the 172.28. Solve this out for h like we did with the airplane one. And so this gives me that this height here is 161.888. And so it's interesting that we can use the law of sines to find a missing one, and then also relate it back to what we just know about sine in general in order to find the altitude of a side, or in this case, the height of the blimp. So I hope this helps as you're moving forward in 10.1. If you have any issues, please feel free to contact me. You'll also notice the very last page is just the summarization of the law of sines in your area for oblique triangles. So it's a good reference point as you're working through this section.